final session of Unit 4. And in this final session, which is session 6, we are going to look at the criteria for organizing the physics curriculum. My name is Patrick Ejay. Now, by the end of this session, you should be able to state the three criteria for effective organization of learning experiences. Then, two, explain each of the three criteria for curriculum organization. Then, finally, give examples, illustrate each criteria for curriculum organization. Now, there are some criteria that should be met in building an effectively organized group of learning experiences. And these criteria are continuity, sequence, and integration. So now let's look into detail what we mean by continuity, sequence, and integration. Now, continuity. Continuity refers to the repetition or reiteration of a learning experience from one level or form to the other. So a particular topic or generalization or theme is revisited throughout the physics curriculum. And you realize that as we mentioned, a particular topic or a generalization or a theme which is being revisited, then this is drawing us back to the dimensions of curriculum organization. So here we are saying continuity refers to repetition. So looking at continuity, in which dimension of curriculum organization will continuity operate? Good. So I know we all said it is going to operate in the vertical dimension of curriculum organization. That is good. Now, continuity is also referred to as the spiral approach curriculum organization. And here, the same topic or generalization or theme is revisited from one form or level to the other, but is treated with increasing complexity or sophistication. So let's take an example, or in other words, we will say that the learning experiences are organized, starting from simple ideas about the concept or principle to increasingly greater sophistication in subsequent years. So like we saw in the previous session, that when we want to teach the concept of waves in year 1, we can teach reflection of light as well as refraction. In year 2, we can teach thin lenses. In year 3, we can teach seismic waves. All these are concepts under waves. However, as we move from one level to another, the content increase in sophistication. So, for instance, the concept motion. We know motion occurs in the senior high school physics teaching syllabus as follows. So that in year 1, we teach kinematics. In year 2, we have circular motion, gravitation, as well as oscillatory motion. Then in year 3, we look at rotational motion. You realize that as we move from year 1 through to year 3, the content under motion increases in complexity. So that in kinematics will be a bit simple, but when we get to circular motion, you realize that it is now increasing in sophistication, and rotational motion also at another level. So this arrangement is from simple ideas about the concept motion, starting with kinematics, to the complex concept, which is rotational motion. Now let's look at sequence. So sequence refers to the arrangement of the learning experience in such a way that one learning experience is a prerequisite and then the next. So whatever you learn will now serve as a prior experience in the next concept or learning experience that you will undertake. And it is therefore an arrangement of a series of learning experiences. And each learning experience in the series is connected with the one before and the one after it. So for example, if our selected learning experiences are momentum, force, and velocity, then you realize that for sequence, where one concept will serve as a prior knowledge to the subsequent concept, then once we have momentum, force, and velocity, then it will be good to start with velocity. And now velocity will now serve as a prior knowledge to force it. So let's take note of this sequential arrangement of these concepts. And this sequential organization of curriculum experiences is also known as parallel organization. Parallel organization. Now let's look at integration. Now integration is the organization of the physics learning experiences in such a way that they interrelate with similar learning experiences in other subject areas. And it is the unifying of all the subjects with common learning experience. So, for instance, if atoms, elements, molecules, and compounds in physics and chemistry are arranged in such a way that the learning experiences such as cells, tissues, organs, and organisms in biology will also be taught around the same time, then the learner gets a unified view of the building blocks of nature. And so when you also compare this to the dimensions of curriculum organization, then we will see that integration also talks about the horizontal dimension of curriculum organization. Students, we have seen that there are three criteria which should be met in organizing physics curriculum experiences for effective instruction. And these criteria are continuity, sequence, and integration. Students, as we bring the session to an end and also an end to Unit 4, let us take this question. Now, organize the following sets of learning experiences to meet the criterion of sequence. Organize these, arrange them so that they will meet the criterion of sequence. So we have question number 1, temperature scales, temperature, thermometric substance. The second question, sound waves, types of waves, and waves. And the last question, work, energy, power, and force. Arrange these concepts to meet the criterion of sequence. Thank you very much for joining this session